Hi everyone, we're back and we are at our question 1 for practice exam 2. Ignore the little typo there. And problem 1. So let's go ahead and let's get at it. I'm going to take, let's go not here, let's go to our course, let's go to our pages because I want to go back and this is looking like a chi-squared problem. So let's see if we can find that Mathematica notebook. Lecture 8, that's a little bit too far away. Actually, but I think we had lectures. Let me go back there for just a second. Let's go back. Yes, lecture 6, Humboldt. Maybe it's there. I'll have to figure this out. Excellent. So we have, actually, we have it right here. Perfect. So we need to look at our observed and expected values, and we're testing whether this sample is normally distributed. So let's go ahead and let's get at it. I am going to, or we are going to, let's calculate the observed. So observed, so we observe 5500, 3900, 10, 1800, between there and there, and finally 3600. Excellent. Now for expected, we need to find, actually, let's go ahead and okay, here we go. Let's do expected one. So we're doing PDF, and we said 50,000 grain size greater than 43 nanometers. So 43, our mean is 45 and then 1. And then our number of samples here is, where is it? Where's the total number? 5, 6, 7, 8. So that's our expected 1 value. And let's look at it all numerically. So that's our expected 1. Our expected 2, greater than that, less than. So now we're going to go from minus infinity to our z function of our measure in less than 45.5, and then we have 45, and then we have 1. Good. And we have our expected 3. Our expected 3, 10 samples less than 42. So again, minus infinity, except now this time will be 42. And then we're going to have expected 4. PDF between now, let's do z function, between 45.5, 45 and 1, and 50. Expected 4, and then finally expected 5. And then we're going to look at between 44.2 and 46. Excellent. So let's start with that. Expected 1, observed, expected. Let's go to our function here. So we get a chi-squared expected of 20.2. So our chi-squared 20.2. In this problem, we have how many outcomes? We have, let's go ahead. What's my length of observed? I believe it's 5, because we have 5 expected. Yes. So our new is equal to 5 minus 1, but we also have 2 parameters from R, so that's going to be 3. So let's go ahead and let's look up, actually, what is this problem? We're not told, so we're going to assume 95%, so 0.05. So 0.05, and we said 5, oops, whoa, 5 minus 1 minus 2, so that's going to be 2. So 5.991, if I am indeed correct. Yes, that is true. So it's chi-squared test, so 5.991. So we know that this is going to be definitely, oh, excuse me, it's 0.1. So let's go back. So 0.1, even worse, 4.6, that's going to be a big old reject. Reject. We have those values. It's not going to work. We got it. So, nope. If I took a measurement sample of vanadium and found that for a sample size of 17, the variance, or actually our sample squared, is equal to 2.1 nanometers, does the sample come from a population with a standard deviation, actually, yes, of 1.4 nanometers? So we're going to have to use, let's go ahead, where's our lecture? Let's pull this bad boy up. So let's go ahead, let's pull up our R. Now we don't have the data set, and it's a two-sided test. And for this one, we're going to have to do, it's 0.025. So let's look at here. So I'm going to have to go in, actually I'm going to go, so in this problem, our chi-squared function, our n was 17, and then we have to do square root of our variance, which was 2.1 for our sample, and then, but our sigma was indeed 1.4. So our chi-squared experimental was 17.14. If we're looking at this sample here, so then we're looking at a chi-squared of 0.05, and then our new, actually let's go back to our lecture 8 here, and actually we can observe, and we can see this here, yeah, 0.05, and it's going to be a new of 16, so we can look at that value, 0.05, actually, yeah, 0.05, and then 16, 26. So we do not reject. We're within the bounds. There we go. That's it. That's problem 1. So let's get on to problem 2 and some air propagation. We'll see you then. Thanks. Bye.